Now f of x is equal to root x, root of 36, that is equal to 6. F dash x is equal to 1 over 2 root x. 1 over 2 into root of 36 is 1 over 2 into 6 is 1 over 12, and h is equal to 0.6. The volume V is equal to x cube. Differentiate with respect to x. dV by dx is equal to 3x square. The approximate change in volume caused by increasing 3%. Find the two numbers whose sum is 24. If you add two numbers, you will get 24. And if you multiply, you will get the maximum value. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. So in this session, I am going to take remaining part of the application of derivatives in this revision class. Today I am going to discuss regarding finding the approximate value, that is approximation, and maxima and minima. Now let us move on to the approximation. So approximate, how to find the approximate value? Let f from d, a function from d to r, where d is a subset of r, be a given function, let y is equal to f of x, then delta x is called the small change, that is delta x is called the small change in x, or it is also called as increment in x, and whereas the small change in y is denoted as delta y. So delta y is equal to f of x plus delta x minus f of x. Therefore, dy can also be written as dy by dx into delta x. dy is equal to dy by dx into small change in x, that is delta x. So if you cross multiply, so the same concept, this can also be written as dy by dx. What is the meaning of this? dy by dx is equal to dy by dx into delta x, means dy is equal to dy by dx is nothing but f dash x into delta x, that is dx. So f of x plus delta x, f of x plus delta x is equal to f of x plus delta x into f dash of x. So what is the formula we are going to use in approximation is f of x plus h is equal to f of x plus h equal to f of x plus h into f dash of x. This is the simple formula which we are going to use to solve the problems. Now move on to the first problem. What is the first problem? So I may expect this type of questions either for 2 or 3 marks. So this may be a 2 mark or 3 marker question, a sure question for the point of examination. Using differentials, find the approximate value of square root of 36.6 up to 3 decimal places. Now what is given here? Given let f of x plus h is equal to square root of 36.6. Now here, just here, this is nothing but x is equal to 36 and h is equal to 0.6. So what is f of x? F of x is equal to root x. Square root of x, what is square root of 36? So square of 36 is equal to 6. And differentiate this, f dash of x, differentiation of root x is 1 over 2 root x, 1 over 2 into, what is root x? 36, that's equal to 1 over 2 into 6, that's equal to 1 over 12. Now just substitute in the formula, that's it. So we know that f of x plus h is equal to f of x plus h into f dash of x. So what is f of x? That is nothing but root x plus h into differentiation of root x is 1 over 2 root x. Now substitute the value. What we got? Root x is equal to 6 plus what is h? H is equal to 0.6 into 1 over 2 root x. 2 root 36 is nothing but 2 into 6, that's equal to 12. So 6 plus 0.6 divided by 12, that's equal to 6 plus 0.6 divided by 12. What is this equal to? So 0.6 divided by 12 is nothing but 0.05. So what is this equal to? So 6 plus 0.05 is equal to 6.05 approximate value. So therefore square root of 36.6 is equal to, what is this equal to? 6.05 approximately. That's it. This is how we are going to solve these type of problems, right? Let me explain once again. So f of x plus h is equal to 36.6 under root x is equal to, here x is equal to 36 and h is equal to 0.6. Now f of x is equal to root x, root of 36, that is equal to 6. F dash x is equal to 1 over 2 root x. 1 over 2 into root of 36 is 1 over 2 into 6 is 1 over 12, and h is equal to 0.6. So here, what is the formula? F of x plus h is equal to f of x plus h into f dash of x. F of x is root x, h into f dash x is 1 over 2 root x. Root x is nothing but square root of 36 is 6, plus h is equal to 0.6 into 1 over 2 into root x. Root x is nothing but root of 36, that is 6. 6 to the 12. So straight away 6, substitute here. 6 plus 0.6 into 1 by 12, that is 0.6 by 12 is 0.05. 6 plus 0.05 is equal to 6.05. So therefore, the approximate value of 36.6 is equal to square root of 36.6 is equal to 6.05. Right. Now move on to a similar type problem. So using differentials, find the approximate value of 49.5. So this is also same as that of the previous problem. Just what is given here? F of x plus h. F of x plus h is equal to, that is square root of 49.5. Now what is f of x? F of x is equal to root x. Here x is equal to 49 and h is equal to 0.5. So f of x square root of 49, square of 49 is 7. Differentiate this. F dash of x is equal to differentiation of root x is 1 over 2 root x, 1 over 2 into root of 49. So this is equal to 1 over 2 into 7, that's equal to 1 by 14. So root x is 7 and that is f of x is 7 and f dash x is equal to 1 by 14. Substitute in the standard formula, that's it. So what is the formula? F of x plus h is equal to f of x plus h into f dash of x. F of x is root x plus h into differentiation of root x is 1 over 2 root x. Now what is root x? Root of 49 is 7 plus h is 0.5 into 1 over 2 root x, that is nothing but 2 into 7 is 14. 7 plus 0.5 divided by 14. Simplify this, that's it. Okay. So if you divide this, 7 plus 0.0354. 0.0354, right? Add this, that's it. Now if you divide this, 7 plus 0.5 by 14 is equal to 0.3571. That's it. Add this. What is this equal to? So this is equal to 7.03571. So approximately this is 7.03557 is equal to 6. 7.036 is the approximate value of square root of 49.5. That's it. Hope you followed, right? So very simple. Just divide. What is the formula? F of x plus h is equal to f of x plus h into f dash of x. F of x is root x plus h into 1 over 2 root x. Root of 49 is 7 plus 0.5 into 1 over root 7, root 49, that is 1 over 2 into 7 is 14. 7 plus 0.5 by 14 is 7 plus 0.03571, that is approximately is equal to 7.036. That's it. Now let us move on to the next problem. Find the approximate change in the volume of a cube of side x meters caused by increasing the side by 3%. This is also an important problem. So you may expect this type of problems also. Find the approximate change in the volume of a cube of side x meter caused by increasing the side by 3%. Now let us write first the volume of a cube. Volume of a cube is equal to, volume V is equal to x cube. Volume V is equal to x cube. Right. Now what is given? V. What is to find? Differentiate this. dV by dx is equal to 3x square. Now what is to find? The approximate change in volume is given by dV is equal to dV by dx into delta x. The approximate change in volume. Now what is given? 3% of 3% of x is nothing but 3 divided by 100 into x. That is nothing but 0.03 times x. So this is small change in x, that is delta x is equal to 0.03x. Substitute here and simplify, I'll get the answer. That's it. So therefore the approximate change, approximate change in volume, is equal to dV, that's equal to dV by dx, that's equal to dV by dx is 3x square into delta x. So 3x square into what is delta x? Delta x is 0.03 times x. Simplify this, that's it. Okay, so just multiply this. 3 into 0.03 is 0.9, that's it. If you multiply 3 into 0.03 is nothing but 0.33 is 9, 09, x square into x is x cube meter cube. So the approximate increase in the volume, that is the approximate change in the volume of a cube is 0.09 x cube meter cube. This is very simple for 2 marks, right? Very simple. See, listen. What is given? The volume V is equal to x cube, differentiate with respect to x, dV by dx is equal to 3x square. The approximate change in volume caused by increasing 3%. So 3% of x is nothing but 3 by 100 into x, that is 0.03x. Substitute here. The approximate change in volume dV is equal to dV by dx into delta x. What is dV by dx? 3x square into delta x. Delta x is equal to 0.03x. That's equal to 3 into 0.03 is 0.09. X square into x is x cube meter cube. So the approximate change is 0.09 x cube meter cube. That's it. Okay. Now move on to the next problem. Now let us discuss regarding the maxima and minima. So then after approximation we are going to study regarding maxima and minima of a function. Maxima and minimum of a function. So you might have been studied, if a continuous function goes on, increases and reaches a particular value, again it decreases, this point is called the maximum point and this point is called the minimum point of a function. So maximum and minimum value of a function. Now for the function to be maxima or minima, suppose if this is a function y is equal to f of x. For the function y is equal to f of x, to find the local maxima or local minima using first derivative test or a second derivative test. So what is the procedure? If y is equal to f of x, let us represent this as equation number 1. Differentiating with respect to x, if you differentiate, dy by dx is equal to f dash x. Differentiate again, d square y by dx square is equal to f double dash x. So for the function to be maxima or minima, for f of x to be maximum or minimum, f dash of x is equal to 0. So if f dash of x is equal to 0, for the function to be maxima or minima, f dash of x is equal to 0. So here you may get a linear equation or a quadratic equation. Say suppose if you get x minus a into x minus b, that is x is equal to a and x is equal to b, let us represent, say you will get two values, right? So now at x is equal to a, when x is equal to a, at x is equal to a, when x is equal to a, that is at x is equal to a, f dash x is 0. If f double dash x is negative, if f double dash x is negative, the function is maximum. Function is maximum at x is equal to a. Similarly, at x is equal to b, f dash x is equal to 0, whereas f double dash x is equal to, if it is positive, then the function is minimum at x is equal to b. So the minimum value, so the maximum value here and the minimum value is got by substituting the value of x and b in the given equation. This is how we are going to find the maxima and minimum value of a function, local maxima, local minima, and even the extreme values, right, critical points. Now let us move on to a problem based on this. Now find all the points of local maxima and local minima of the function f given by f of x is equal to x cube minus 3x plus 3, right? Now this is given problem. F of x is equal to x cube minus 3x plus 3. Differentiate this. Differentiating with respect to x, what you will get? F dash of x is equal to differentiation of x cube is 3x square minus 3. So if you want, you can differentiate again. F double dash x is equal to 6x, right? Now for the function, for f of x to be maximum or minimum, f dash of x is equal to 0. That is, what is f dash x? 3x square minus 3 is equal to 0. So you can take a 3 common factor, x square minus 1 is equal to 0. Therefore, x is equal to plus or minus 1. X is equal to plus 1 or minus 1. So these are called the critical points, right? Now at x is equal to 1, f dash of x is equal to 0, whereas f double dash x, substitute here. So this is equal to 6. That means it is positive. Positive means the function is minimum. Therefore, the function is minimum. Therefore, the function f of x is minimum at x is equal to 1. Now, just put x is equal to 1 in the given equation. So, you will get f minimum is equal to 1 cube minus 3 into 1 plus 3, that is 1 minus 3 plus 3 gets cancelled, that's equal to 1. So, the function is minimum, the minimum at x is equal to 1 and the minimum value is equal to 1, right? So, this is called the local minimum. Similarly, at x is equal to minus 1, at x is equal to minus 1, f dash x is equal to 0, whereas f double dash x, so what you will get? 6 into minus 1, that's equal to minus 6. Negative. Negative means the function is maximum. Therefore, the function is maximum. Now, the maximum value is got by putting x is equal to minus 1 in the given equation. So, that is f maximum is equal to, substitute here, x is equal to minus 1 whole cube minus 3 into minus 1 plus 3. Minus 1 whole cube is minus 1, it is minus into minus plus 3 plus 3. So, 6 minus 1 is 5. So, the maximum value is equal to 5. Therefore, that means the function f, the function is minimum and the minimum value is equal to 1 at x is equal to 1 and the function is maximum, the maximum value is 5 at x is equal to minus 1. This is how we are going to find the maximum and minimum value of the given function, right? So, they are called as local maxima and local minima of the function. Now, move on to the next problem. Now, this is very important problem for 3 marks. You may expect 3 marks. Find two numbers whose sum is 24 and whose product is as large as possible. So, find the two numbers whose sum is 24. If you add two numbers, you will get 24. And if you multiply, you will get the maximum value. So, find the two numbers whose sum is 24 and whose product is as large as possible. Now, let us consider the two numbers. Let the two numbers be, one number is x and the other number will be 24 minus x. Suppose if x is one number, then the other number will be 24 minus x. Now, let us say let y denotes the product. Suppose if y denotes the product of two numbers, then y is equal to one number is x, another number is 24 minus x. So, if x is one number, then 24 minus x is the other number. Let us consider y is the product of two numbers. If y is the product of two numbers, then y is equal to x into 24 minus x. Simplify this. Y is equal to 24x minus x into x is x square. Let us represent this as equation number 1. Now, differentiate with respect to x. Differentiating with respect to x, what you will get? Dy by dx is equal to 24 into differentiation of x is 1 minus x square is 2x, that's equal to 24 minus 2x. Differentiate again. If you differentiate again with respect to x, differentiating with respect to x, what we will get? D square y by dx square is equal to 24 constant 0 minus 2 into 1, that's equal to minus 2, negative. Negative indicates the function is maximum, right? That's it. So, here this is negative, that means less than 0 means therefore the function is maximum, right? Now, next, for the function to be maxima or minima, function to be maximum or minimum, what is the condition? F dash of x is equal to 0. What is f dash of x? 24 minus 2x, that is 24 minus 2x is equal to 0. 24 is equal to 2x, x is equal to 24 by 2, that's equal to 12. So one number is 12. When x is equal to 12, the other number will be, other number is, what is the other number? 24 minus x, that is 24 minus 12, that's also equal to 12. So therefore the two numbers are 12 and 12. So if you add 12 plus 12 is 24, and if you multiply 12 into 12 is 144, which is the maximum value. That's it. Okay. See here, d square y by dx square is equal to negative at x is equal to 12. D square y by dx square is equal to negative. D square y by dx square is equal to negative means the function is maximum. Function is maximum. So therefore, when x is equal to 12, the function is maximum. So one number is 12, the other number will be 24 minus x, that's equal to 2. So therefore, the two numbers are 12 and 12. If I add these 12 and 12, what you will get? 12 plus 12, the sum is equal to 24. Sum. And the product 12 into 12, that's equal to 144. This is the maximum value you are going to get. This is how we are going to solve these type of problems. Hope you followed. So you may expect this type of questions for your final examination for 3 months or for 2 months. Right. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.